Bonding in elements and compounds. In this video, we will cover ionic bonds, covalent bonds, and metallic bonds. But first, let's look at bonding. What is a bond? A bond is an attraction between two or more atoms. But why do bonds form? Elements form bonds in order to receive a full valence outer shell. Now let's move on to ionic bonds. To understand what an ionic bond is, we first need to understand what an ion is. An ion is an element with a positive or negative charge as a result of losing or gaining electrons. If it loses electrons, it's a cation, and if it gains electrons, it's an anion. So what is an ionic bond? An ionic bond is an electrostatic force of attraction between oppositely charged ions. Now let's look at an example of ionic bonding between sodium and chlorine. Here we have illustrated the valence shells of both sodium and chlorine. Notice that they both have opposing charges of +1 versus -1. In ionic bonding, the electrons are exchanged, so sodium will give its one valence electron to chlorine, so that both of them will have a full outer shell. The final product here is sodium chloride, or salt. But how would we show this in Lewis structure? When using Lewis structure, we'd need to use brackets to show the charge. We'd also need to turn the crosses into dots. Now let's look at an ionic lattice. Here we have one layer of an ionic lattice formed by sodium chloride. So what is an ionic lattice? An ionic lattice is an orderly array of positive and negative ions. Now let's move on to covalent bonding. So what is a covalent bond? A covalent bond is a bond formed between two or more atoms by sharing valence electrons. Let's look at an example of covalent bonding between hydrogen and chlorine. Here we have the valence shells of hydrogen and chlorine. As it's covalent bonding, we don't care about the charges. In order to have a full outer shell, hydrogen needs one more electron, and chlorine needs one more electron. So both of them will share one electron each, allowing them to both have a full outer shell. But how do we convert this to Lewis structure? First, we need to remove the circle for the outer shell and move everything a bit closer together. Then we need to turn the crosses for electrons into dots. Then we'll replace where the bonded electrons are with a line and remove the circle for the nucleus, leaving us with this. Here are some more examples of covalent bonds shown with Lewis structure, where each line represents a covalent bond. Now let's look at a covalent network. Each group of atoms is held together by covalent bonds, and those groups are held to other groups by intermolecular forces, but that's for another video. Another structure of covalent bonds is a covalent lattice. Carbon's allotrope of diamond is a covalent lattice. The lines and dashes represent covalent bonds. Silica, quartz, is also a covalent lattice. The silicon and oxygen form an infinite network of bonds. Now let's look at the difference between ionic and covalent bonds in terms of electronegativity. But what is electronegativity? Electronegativity is the tendency for an atom to attract a bonding pair of electrons. So how does that determine the difference between ionic and covalent bonds? Well, the bigger the difference in electronegativity, the stronger the force of attraction between the bonding electrons and the atom. This will allow for electrons to be exchanged, resulting in an ionic bond. If the difference is small or equal, the force of attraction will not be strong enough for the electrons to transfer, and the bond will be covalent. Let's look at some examples. This periodic table displays the Pauling's electronegativity values. Once again, we'll look at sodium chloride. Sodium has a Pauling value of 0.93, whereas chlorine has a Pauling value of 3.16. This is a big difference. Therefore, the bond will be ionic. Now let's look at hydrogen chloride. Hydrogen has a Pauling value of 2.2, whereas chlorine has a Pauling value of 3.16. This is a small difference. Therefore, the bond will be covalent. Finally, let's look at metallic bonding. So what is a metallic bond? A metallic bond is an array of cations positive ions immersed in a sea of delocalized electrons. And that's all for today's video. Thank you for watching.